Okay, the lesson will start very soon. You hear my voice, right?
Yes.
Yes.
Thank you. Yeah, thank you. Now, so today we will go over with you on the long questions. So please take a look at page 27. We have got altogether 8 questions. Of course, we cannot finish them more, but I just highlight some of the questions to have you have a start, and later on you may start to do the following questions by yourself. Okay, I would like to check your answers later. Now, while we are waiting, you may start to do 14. Question 14. For each of the following reactions, which suggest the one with reasons, the method that can be used to follow the progress of the reaction. So please do question 14 as a start. I'll turn on the camera and let me know you're here. 吳日軒、鄧浩堯、黃清華 ，are you here？ 鄧浩堯、黃清華。Now the way to wait until Wang Qinghua comes. Only him missing. Now, you may take a look on this question. Structure type questions. You may take a look for each of the following reactions, such as with reason. Okay, one method that can be used to follow for progress of the reaction. So it's a double check of your understanding of the type of reaction, and you need to one hint I need to give you is on the observation. Based on the you tell me the different methods to use for A part. Take a look on the A part, for example, A part. What do you think? What is the observation? Now, once you know the observation, you know the method. What method can be used? Yang Zhongyi, A. What method can be used?
The student can look at the color of the precipitate.
You mean there is a color change?
Yes.
From what to what? Change. What is the change?
Colorless to blue-green.
Colorless. Which solution is originally colorless? And what is blue finally?
a bluish green solution to bluish green precipitate.
Bluish green precipitate. Which chemical will have bluish green precipitate?
The solid copper.
Solid copper. Copper is bluish green. Agree? Copper is orange green. Bluish green, is it? Now I know it will be rather confusing. You would consider the only on the solution. If I take a look on this angle, you may find there is a change in color of the solution. So what will happen about zinc solid and copper solid finally? Where will they be found? In the solution mixture, eh? It under what, to be more exact, what position would you see those solid? Is it uniformly suspended into the solution or what? Sink, float, or what? For example, we have got copper. Now, indeed, copper is a reddish brown powder. Where you will find it exactly into the solution mixture? Top layer, bottom layer, or just suspended throughout the whole solution? Uniformly.
The bottom layer.
Why?
Because copper is heavy.
Heavy. So please use more scientific terms of heavy, right? You use the term density.
Denser than water.
Yes, denser, much denser than solution. So they will sink at the bottom. So if you really want to keep track of the reaction, don't worry about the formation of powder. So even though there's powdery solid, if they will finally sink at the bottom. So we focus on what? We focus on the solution, the color intensity of the solution mixture. How will you change it? So the method to be used, we will call it as colorimetry. So all of you, the first point, you should get addressed to the point about the name, right, of the method. We call it colorimetry. All of you, please mark it down. Colorimetry. Now, during the whole progress, during the whole progress of the reaction, the blue color of the copper to sulfate, okay, will become paler. Okay? The change in color intensity of the blue solution. So you know that it is mainly due to the presence of copper 2 ions. Which means the concentration of copper 2 ions decreases. So the change in the color intensity solution can be measured by the as absorbance. Okay, as absorbance by a instrument. What is that? Apparatus. What's the instrument? What is the instrument?
Colorimeter.
Colorimeter. So, first of all, tell me the observation, and this is due to the concentration of copper 2 ions drop. So, what are you going to do is to have an instrument, an apparatus to measure what? the color intensity of a blue zone? How? You are going to use the term absorbance. So at least you need to tell me the spot for me, the what is the observation change, okay, to be considered, to be highlighted, and you think of the suitable instrument or apparatus for you to keep track of such change. Can you get my point? So in this sense, you may find calorimetry. Calorimetry would help because I use calorimetry to measure the change in absorbance. They can more or less reflect the concentration of coupled ions, okay, which is blue. So why can it be done? Because absorbance is directly proportional to concentration of solution. So by measuring the change in absorbance, which means that I can indirectly measure the change in coupled ion solution. Okay, why we spot that is coupled ion? The concentration of it should be considered is because during the whole progress of a reaction, the blue color becomes paler. So there is a drop in color intensity of the coupled ion solution. Can you get the logic? The whole flow of the logic will be this. So that's why if you want to know quantitatively how blue the solution is or how pale the solution is, I should use some instrument. The instrument is calorimeter. Do you understand? So some keywords should be looked at. So some keywords should be highlighted here. So, but all those should be based on the observation. You start from observation first of all. Any questions? You understood? Matthew, you understand what is happening here?
Yes.
Yeah. So, for the calorimetry, right, it is suitable to be used for the reaction involving a. What type of reaction would be suitable to you for using calorimetry, right? Which type of reactions? The reactions involving color change. I use this, okay? No matter it is from darker blue to paler blue or in reverse, from colorless to start to become more deeper blue. Okay, so you can also use this method. B.
We can measure the change of volume of the gas.
Okay, the method is the change in volume of the gas produced. Somebody, if you want to get the data, you will use the word at regular time interval. So this is for human. For example, every 10 seconds I get the data. But if you use the word continuously, so you are going to tell me what instrument you are going to use. Okay, you get my point. For example, the sensor that will keep track of the reading, change in reading. I rapidly transmit that reading data to a computer. Okay, and they will show you in terms of a graph. So this is the way to do the continuous data. But if you mention it as regular time interval, and that is you to be responsible to take the reading by your own. Okay, using your eyes, right? So it depends on how fast you can take the data. Every 10 seconds, every 20 seconds, every 30 seconds, for example, and you're going to take the data by yourself. If you can manage, you can do it every 5 seconds, 2 or 4 seconds, or even 1 second. It's up to you, as long as you can solve. Okay, so the regular time interval would indirectly tell you who to keep track of it. If you write down the continuously, which means that the computer help. Of course, computer alone cannot do. So you usually use the term somewhat sensor connected to data locker, that type of saying, right? So you should be aware of this. So tell me the reason why can we keep track of the reaction progress by measuring the change in volume of the gas produced. Why? What is formed during the whole when the reaction proceeds?
The reaction will form the oxygen gas.
Yep, oxygen gas is produced. So remember, while you get match of those two, right? So you will need this, right? Highly needed. And besides you do action, you may think of the measure the change in pressure. Okay, the change in gas pressure in the reaction mixture. Now, somebody would love to write using this method, right? But remember, this is the keyword because you are going to measure the change in pressure, and any change in pressure is due to the formation of a gas. You must carry this in a closed vessel or closed container, or you would say that you are going to have a sealed container. Okay, can you get my point? So I will give you a hidden message that the volume, okay, the volume inside the system doesn't change. Remember, the system inside should be having the same volume all the time. Now, otherwise, if you let the gas formation forms, and they will help expand the whole system. Now, just like number one, method one, what will happen? So the pressure will not further increase. Okay, so they will have a balance of the pressure inside the container and outside container, right? By simply pushing the plunger. So if you let the system expand by itself, for example, the container will have a movable piston or the movable plunger, right? All those that are movable. The pressure to be measured is meaningless here because the pressure will become constant all the time. But once I put it into the sealed container, what will happen? Whenever some gases that form, they will have more chances of heating of the gas particles hitting the wall of the container, resulting in higher gas pressure. Can you get my point? So the term at this closed vessel in a sealed container of fixed volume, all those wordings, they are highly needed in order to let me know you understand science. You understand? It's quite different from the first method. First method, this time I need to measure the whole thing at constant pressure. This one, we will measure it as constant pressure. But for second part, you are going to measure at constant volume. It's different. Now, if you get to know more about physics, it is something related to the gas law. PV is equal to nRT. N refers to the number of volts of gas. T refers to absolute temperature. R is the gas constant. P and V, their pressure and volume respectively. So if I change either one of the factors, they would affect the others. Can you see that? So whenever you do such, we are going to keep other factors the same. So why you are going to, during the whole progress of the reaction, here comes the reason. As the oxygen gas is produced, so what will happen? The gas pressure will build up, right? So you are going to tell me because of that, I would know I will use this physical property. This will change the physical quantities as a measurement method, right? In this type of reaction. Can you think of the third method? Is there any other method besides measuring the change in volume of gas at constant pressure, measuring the change in gas pressure at constant volume? Can you see that? That two sentences is just the opposite, right? If I keep the temperature the same, this one increase, okay, you may lead to pressure increase or volume increase. If I keep pressure the same, volume increase. So example, increase between E and N. There you go, my point. Is method 1. Method 2. R and T should be the same. N increase. If I keep volume the same, the pressure will increase. If you use method 2, which means that the number of N produced will reflect the pressure. Can you get my point? You understand? Say something about physics. How about number 3? Third method. Can you think of the third method? Measure the change in what? Okay, third method. Oh, somebody say that you cannot hear me so clearly. How about the others?
Your voice like in the 好似真空講嘢咁。
How about at this moment? Is it better?
即係好似帶住咪套講嘢咁樣。
Is it better? Is it better? I would like to adjust a little bit. Is it better? Okay. Is it better? Is it better? So I may with hands covering the recording part. So maybe this, right? You cannot hear so clearly, right? Just like scientists, you are going to get to know the reason. This one no good. This one better, is it?
Yes.
So I know the issue, right? Maybe I just hold them for long because I'm not holding the iPad. I just hold that for long so that you cannot hear the voice. But one, I take it out like this, better, right? Yeah. Okay. Thank you. So, please see that you are going to change. You measure the change in mass of solution mixture, reaction mixture, and it is because of what the oxygen gas is produced as the reaction proceeds. So what will happen is that they escape. Okay, it escaped. So it will experience a drop in mass. Okay, is that clear? So we have got the method 2. How about C? We've got this. Any method to keep track of the reaction? Leaking hope. What is the method?
Maybe measure the change of the gas produced.
Measure the change in gas produced. What physical method? what physical quantities would be measured for your case? You just say that change in gas, right? Change in what of gas?
The nitrogen dioxide.
Nitrogen dioxide. What of gas refer to the physical quantities? For example, the mass of the gas, pressure of the gas, volume of the gas. So what of gas you are going to measure?
The volume of nitrogen dioxide.
Volume of nitrogen dioxide. How? Now, so you may have this, right? NO nitrogen monoxide, we've got O2, we've got NO2. What would you expect to be in the container here? You will have that 3 gases separately. Do you mean that? Or they just get mixed?
Maybe the after the mixing.
Yes, mixed. So how will you know? How will you know the volume of NO2? So what is the design of a container? Is it a container of fixed volume? Or is it a container of which can have a constant pressure, which means that this one, for example, somebody will say that we've got a container with a piston, okay, with a piston. So you know that what is mean by piston? Anyone who watch NBA, you can get what I mean. Okay, piston. It is movable. You don't know what's that? 活塞啊！喂，冇嘢啦，即係你哋屋企做緊乜嘅？你哋我乜都唔識嘅，我係好驚喂。嗱，第一樣嘢 for free gases, including reactant product, because they are free moving, they will finally get mixed well. So we cannot measure the volume of NO2 only. Okay, you get my point. So keep in case we have got a the reaction involving all 3, okay, all 3 species being gases. So what should be done next is to check what? Now check this. Check the stoichiometry. 3 moles of the gas, they will form 2 moles. Can you think of a method?
Pressure change.
Yep, pressure change. But can we use this design? If I really want to keep track of the pressure change, can we use this design? The volume of the container which can be adjusted upon the change in pressure. No. Instead, we do not use this method. We will use what? A container which is sealed. Yeah, it's sealed and with the constant volume at all time, right? For the whole progress. So this is the method they are going to use. Do you understand? Because for this, we have got the same volume, but the pressure, in case the has got a pressure change, I know the number of moles of gas change. Can you get my point? How about this case? After the progressive reaction, what will happen to the pressure change? Will it increase?
Decrease.
Yep, decrease instead this time. Why?
Because the moles decreased.
Yep, the moles of the gases decreased from 3 moles to 2 moles. 3 moles on the left-hand side, 2 moles on the right-hand side. Do you realize? So if you have got the fixed container, which means that the total number of particles, okay, they will drop in the total number. So you have got a total number of particles drops, which means that there will have a less occurrence of a heating the container of the wall, which means that the pressure it drops. It's something related to physics, right? So you are going to measure the change in gas pressure. Remember some keywords. In a what container? If I write so, some keywords in a what type of container? You take a look on the sentence on top. Do you understand? So this is a saying. In a closed vessel or like this, the one which shown in blue. Do you understand? So what's next? So during the whole progress of reaction, what will happen? 3 moles of gases would be react to give 2 moles of gases. So the pressure will happen, drops, decreases. Okay, as the reaction proceeds. Do you understand? So the change in pressure can be monitored. Okay, the change in gas pressure can be monitored by what? Now it's not the end, right? By what? So this is what the supplementary information to be used. So a similar case as this, you should also write such afterwards. Okay, you should also write such in other words. So this is the instrument, the pressure sensor connected to the data logger. With it or with a data logger connected to the computer. Somebody, you really want to talk about a continuous measurement. Well, this is the way. Do you understand? What else? Now this is the method. Can you think of another method? Yes, you can. Do you know the color of the 3 gases? Anyone who knows the color of the 3 gases? Nitrogen monoxide is colorless. Oxygen gas, of course, colorless. How about NO2? Please search on the web. Tell me what is the color of NO2. You type it on the web now.
Reddish brown.
Yes, a brown gas. So you are going to use colorimetry as well. You can also use colorimetry. Can you get my point? So if you write down it as a colorimetry, so what should be done? You are going to measure the change in maybe I cross them out here. Another method that you may use is that I do the same. I will have the same container, but I keep track of the color changing color intensity. Okay, so again, colorimetry, and how you are going to measure the change in color intensity of the reaction mixture, which is blue, but this is brown color intensity of this reaction mixture. Why? S, NO, and O2 are colorless, while NO2 is brown. The concentration of brown NO2 increase, which means that the color intensity of brown reaction mixture increase. So how would you measure the change in color intensity of the reaction mixture? This is monitored by measuring what? Its absorbance with what instrument? Colorimeter. Do you understand? So this type of saying, the one in blue, is quite similar to A, isn't it? Very, very similar. So I do hope by having a try on this question, will you start to realize how to write down the script, some of the description on the progress of a reaction. Any questions so far? You got it? So my points to address is that you should be able to take care of the wordings, okay, word by word, such that you know what to do. It is highly needed. Now, I would like to do question 15, 16, and 17 today. Now, while for the other 4 questions, I would have it in Chem 2 lesson, okay? So you better watch the video afterwards, such that you know those questions, okay? Now, because I don't want to have the 2 videos nearly of the same content. So I would like to have a slight change. For Chem 1 students, you do those questions that will be different from Chem 2. You know the tricks? So, and then you can watch it by yourself for the remaining half. 15, zinc reacts with dilute sulfuric acid to form hydrogen gas. The progress of reaction is followed by monitoring how the volume of the gas releases changes with time. Draw the experimental setup for monitoring the progress of the reaction based on the graph. Can you guess? Can you guess how? Draw the experimental setup. So what will it be? What will it be? Could you please locate the page for me in the textbook? How will you draw that diagram? Which page? Which page? Oh, okay, which page? Such that you can have this curve. Find it. Which page?
14.
Sorry?
14.
14. Take a look. Page 14. Or you will use displacement of water. So 14. Agree? All of you agree? 14. 14. Agree? Yong Seng-hin, do you agree? You use this setup?
I agree.
You agree. Why?
Because hydrogen gas is not soluble in water.
Oh,
We can use this method to collect the H2 gas in the water trough and the measuring cylinder in the water trough.
yeah. Oh, so you mean you are going to use displacement of water? Now, it's a little bit different because for 36.2 class practice in page 14, hydrogen is a reactant. Can you see that? Hydrogen is reactant. So during the whole progress of reaction, water level will rise up. Okay, will rise. So over time. But if you use the setup, for your case, what will happen? This time the water level inside the measuring cylinder will drop instead. Because oxygen gas will occupy the space. Can you get my point? So the same setup, but the observation will be different. Okay, in this case, the water level will rise, but in your case, if you write it like this, for your case, your setup, the water level inside the measuring cylinder will drop. Do you understand? You understand? Both of you understand? Oh, Hin and Yong Seng-hin, if you reuse this method. So, but the direction of what hydrogen is different. Of course, you may think of this because you are mentioning the change in volume. So you may also use this method. Can you get the point? A shakedown method. Just have a separation of the two chemicals by putting, for example, the solid into the plastic well, and the whole setup it is in a conical flask, and this will be connected by the gas syringe. If I start the timer, you do this action at the same time, you are going to get mix of the two. It's done by swirling the solution mixture. Okay, you try to shake down those to let the solid with a chance to meet the exit, such that the hydrogen gas formed, they will push the plunger of the gas volume, resulting in the increase in the volume of the gas. Can you get my point? Both method is possible. Do you understand? This time, which means that you are going to use this method. You change this one as I change it to magnesium, while I change it to dilute sulfuric acid. Do you understand? And then draw the same setup. But if your case, if you use this one, so what should be written here? So you are going to do something similar. First of all, magnetic stir with a hot plate, you need not do so. Okay, you need not, it's not so necessary, because as long as you have got the magnesium powder and the sulfur acid, that type of reaction is fast enough for you to produce hydrogen gas. So you need not swirl it. Of course, somebody may argue, if I have so much powder, okay, in case the magnesium powder is too much, or zinc powder is too much, what will happen is that they will sink at the bottom, so they will affect the surface area of contact between the acid and the metal will much affect, and because of that, you may use the stirrer. Okay, you need it or don't need it, they will not affect your marks. Okay, you get my point. But for the another setup, please show me that you are going to collect the gas using collection of water underwater. While for those delivery tube, it may not be that long. You need not to be that long, because the hydrogen, as long as the mouth, the end of the tube is just inserted inside whatever position of the measuring cylinder, this will be okay. Any hydrogen gas will be formed will just rise, it will be accumulated inside the container. Do you understand? Do you understand? You know what to draw for this one? Understood? 你明唔明我講乜？A 嗰個畫邊個啊？ 畫14嗰個啊，定係畫第12嗰個啊？你好，
第10嗰個。
第10嗰個，咁14畫唔得啊？
或者但係要查啲嘢，改啲嘢咯，改翻嗰啲 label。
咁其實兩個都係要改噶啦，啲 label 要改嘅。Please take note of the two chemicals, zinc and dilute sulfuric acid, and remember to spell the word gas range. Or is it a reason for using collection underwater instead because you don't know how to spell the word range? I don't know. Now B, the curve below shows how the volume of hydrogen releases changes with time. State the meaning of the term rate of reaction. 曾浩正 Define definition, right? State the meaning of the term rate of reaction. What is meant by rate of reaction?
The time required to finish the reaction.
Time required to finish the reaction. Okay, rate of reaction, does it you mean that whenever you talk about the rate, it usually refers to the time for completion of a reaction. How about initial rate? How about initial rate? After I know the data, do you mean that it will tell you the time for completion of experiments? Can I have a saying of a rate of a average rate of a reaction in the first 10 seconds? So what is the meaning? Are we going to get to know the whole progress, the time for the completion of the reaction? It seems no, right? So indeed, rate of a reaction, it is a measurement of the change in concentration. All of you, please mark down. Of the reactant or product per unit time, but not telling me you the time for the completion of experiment. That you may see the word, a very cleverly written word, per unit time. So you can just like what Zhang Hozheng has been saying, you just put a start button and press the stop button until you find there will be no more further change in observation. So while for that time it really reflects the time for the completion of reaction. But once you would expect there is a change in concentration of a certain reactant product from certain number to 0 or from 0 to certain number, doing this mathematical treatment, right, by dividing over the time of completion of experiment will not lead you to get the instantaneous rate of reaction. What you just got is the average rate of reaction, which means that what Zhang Hozheng has been saying is that they just measured this one is 0 and they will mark it here and what is the time t. So what you are going to find out the volume versus over time. The rate of reaction, it just tell you the average rate. Can you get my point? Because you just have 2 points. While the 2 points that will help you draw a triangle here. While the slope, it is the rate of reaction. But remember, per unit time, it is upon your design. If the certain time with the time is at less as minimum 0.1 second, 0.111 second, or 0.00 so many 0 and 1 second, etc. So you're nearly approaching the instantaneous rate. Give me that. Describe how the rate of formation of hydrogen changes with time. So describe the shape of the graph. 何本正
Yes.
Yeah. So describe the trend.
The initial rate is the fastest.
The initial rate is the fastest or highest, yes.
The average rate of reaction decrease by time.
Okay, decreases over time. So which means that in the middle, right? And then first here, the second will be here. How about this? Number 3. How would you describe number 3? The rate becomes
0.
Yep, becomes 0. And then, which means that what?
Which means the reaction has ended.
Has ended or completes, right? The reaction completes. Has gone to completion. Okay, when it's complete, the rate of reaction drops to 0. Highest decreases 0. So corresponding timing. So we find that this sentence for this, the second sentence, you talk about this, the third sentence, you talk about this timing. Just describe, right? Mr. Chin, would there be a chance of asking for explanation? Yes. Yes, you will have a chance. So you will get to know more about the collision theory in this next chapter. Question 16. 寫晒未呢度? Can I have question 16, your turn. In experiment, gas X reacted completely with solid Y to form gas C as shown in the equation below. Calculate the average rate of formation of Z in the first 10 minutes. And then B, based on the answer in A, deduce the average rate of consumption of X in the first 10 minutes. Something about mathematics. Yep. So how you can approach the problem? Average rate of formation of Z in the first 10 minutes. First of all, get the number. Yes. What number, what data should be got?
0.37.
0.37. At what time?
First 10 minutes.
First 10 minutes, which means that 10th minute. Do you understand? Do you understand what is meant by first 10 minutes and 10 minutes and at the 10th minute? Do you understand? In the first 10 minutes, which means that from here to here. But you say that at the 10th minute, which means here. 唔明英文問題啊，頭10分鐘即係0分鐘到10分鐘嘛，第10分鐘就啱啱好喺喺10分鐘個位咯。Try to get the data at the 10th minute. Now, you need to be highly aware of what you just said in English. It will be about 0.3 something. 3 what?
7.
Or 37 or 38, right? 37. The unit is?
Mole per dm cube.
Okay, mole per dm cube. So what's next?
And divided by 10 minutes.
10 minutes. Yes, that's right. So what will you get? Because you just write down average rate. Okay, you see that? Average rate. So this is measured as this. Okay. With that data and average rate here. Okay, average rate, you are going to find out the slope, slope of this line. Okay, so it is fine, and just copy the whole thing in your long questions. You write as 0.37 mole per dm cube. 2.4 isn't it, right? So you may find this one is 10 minutes. We have got 0.37 coordinate, right? While for this one is 0, 0. So y2 minus y1 over x2 minus x1. So you may get 10 minutes. Okay, so what is the answer for that? 0.037 unit mole per dm cube per minute. So if your unit is wrong, the whole thing no marks. You will score no marks in it. B, based on the answer is A, deduce the average rate of consumption of X in the first 10 minutes. 鄧浩堯 consumption formation consumption, there will be use up, formation which means produce. 鄧浩堯, so what's the answer for B?
(0.074)
or 0.074 unit, please.
Mole per dm cube per minute.
Yep. Reason.
2 mole of X can react with 1 mole of Y will produce 1 mole of Z.
So for every consumption of 2 moles of X, we will produce 1 mole of Z. So that is what you have to say, right? So 2 moles of Y, okay, reacts, 2 moles of X, sorry, 2 moles of X reacts with 1 mole of Y to form 1 mole of Z, right? So because of that, so you may know that it is the average rate of consumption of X in the first 10 minutes. It is equal to what? 2 times the rate of formation of Z in the first 10 minutes. Do you understand? Do you understand this statement? You understand? That the most important step is to get to know this relationship. Well, this sentence comes from the equation. What information the equation just gives you is about the mole ratio. For every consumption of 2 moles of X, they will come to the formation of 1 mole of Z. Do you understand? So here comes the last question, question 17 for your class. Question 17. The decomposition of the dinitrogen pentoxide in a suitable solvent produces nitrogen dioxide, which remains in the solution. Now that one. And the oxygen gas, which is given off. Here comes the equation. So to draw the label diagram of experimental setup that we use to follow the progress of the reaction and give the measurement we would like to take. Wow. From this, how will you get that? How will you get the experimental setup? What can it be? Draw the setup. Please suggest the method before you draw. John Dutler.
Change in mass.
Change in mass, right? If you step back to change in mass of a solution mixture, what diagram which diagram can be modified? Which page? Can you locate the page for me? Change in mass.
Change in mass. 12.
12. Take a look.
No, 13.
13. 13. 13. Change in mass. 12 is also possible, right? 12. This one, the experimental setup, right? The setup is this page, right? So you are going to have a cotton wool. I place it just the neck of the container while we put N2O5 underneath with an electrolyte balance. So just change the chemicals, the name of the chemicals to what you want. Can we think of another method? Can you think of another method?
By the change in volume of
change in volume of
O2.
Of O2. So change the volume of gas, you mean, right?
Yeah.
Yeah, change the volume of gas. Now, why would Mr. Chin would not tell it as change in volume of O2 instead? Because inside the container, for example, here, you would have air inside, right? Can you see the space just above the container? It's just air. So because of the whole setup, you are going to draw something like this. You will have N2O5 underneath, for example. You will have something like that, okay? Now, because we've just got one type of chemical, just N2O5. So this is original air, but later on, O2 will be formed and get mixed. So the change in the volume of that is not necessary to be just oxygen or O2. Okay? In reality, the gas inside is still get mixed with air, but because of the displacement, right? Because of the gas expansion, the matter. So I merely take a look on the volume expanded. I can refer to the volume of oxygen collected. Can you get the point? So I will say the collector gas, the volume of gas instead of collector volume of oxygen. Do you know the difference?
Yeah.
你明我講咩啊？
明。
Yeah. So I would modify the wordings a little bit. Of course, you need to measure not only the volume but also the time. Now, both cases you need to take note of the time instead. Otherwise, you cannot get to know the change of it by calculating the rate. How about the third method? 有冇第三個方法㗎？有。Now, because N2O5 type of the web to check the color of N2O5 and NO2 in solvent, then must be a color change. So you would use this setup, very similar setup, to keep track of that. And I put this time the sample being N2O5. This time is N2O5 to keep track of it. B, again, calculation. Now, here comes the calculations. Now, either method is possible, as I said before. This one. So what is the dotted line? What is that dotted line? Now, indeed, the curve, it is what you would expect, while the dotted line is the data treatment. What this dotted line here means? Lim Hiao Feng, what does that dotted line means? Hello, Mr. Lam.
Yes, let me see.
Let me see. Oh.
The tangent of the curve of the internal rate of reaction.
Oh, initial rate. You mean initial rate?
Yes.
Yep, initial rate at the start of the decomposition, which means that initial rate. So you're going to have at that point and draw a tangent. And so this is what you may find on 2. Determine its slope and you can get 2. If you write down the average rate of decomposition in the first 30 seconds, how would you draw that? How would you draw that? Chen Yu, how would you draw that? Average rate of decomposition in the first 300 seconds.
I'll draw it. I think. Let me think. Wait.
Say it again. I cannot hear so nicely. So what will the change? We have got 2 data. One is at 0 seconds. At 0 seconds. So what is the data? Is 0.02. So how about at 300 seconds here? So what will be the data? Maybe you would use the ruler for help, right? Draw the 2 straight line. This is the 1. And then you are going to
it's 0.012 mole per dm.
Yep. 0.012. So this is the way you have to do doing exam by yourself. Okay. So this is the 0.01 or 1/5, right? So this is 0.012. Do you know what to do? 300 seconds, 0.012. So what is the hidden message? You have got this point, and for A part, for first part, you are going to draw a straight line connected to 2 points, and you are going to determine its slope. Can you get my point? But because I say that it's decomposition, so it is the negative slope. Okay, please write down negative slope, which is the average rate of decomposition in the first 300 seconds. All of you, please mark it down, negative slope. But next time, while you plot the graph with a positive slope to tell you the formation of certain product, So you need not put that negative. Now, anyway, you will see that the data will show you a negative, right? But if a negative with a negative sign, put it again, you know that here comes positive. Okay, you get my point. So we have got 2 points. One is 300 at 0.012. While this one, it's a 0.02 at 0.02. Okay, you get my point. So you are going to put it as y2 minus y1 over x1, x2 minus x1. So you may unavoidably find a negative value in the numerator. So that's why I need to do a minus. Remember to put a minus. Otherwise, it's not correct. Can you get my point? Why do you realize why, Mr. Chin, you draw a negative sign here at the very beginning? Because I find the slope is inclining downward. I must know that it gives you a negative data. So I do such mathematical treatments. So what is the data and what is the unit? Chen Yu, please continue.
The unit is let me calculate. Wait.
Now I would like to invite Ho Qiwan to do the final question. Ho Qiwan, please start over the final questions. I will ask you.
Wait, I just missed something.
2.67 mole per second. Minus 2.67 times 10 to the power minus 5 mole per second. Agree? No marks. No marks. I found so many people smiling at you. Hopefully that smile is not a tease.
Oh, sorry, it is positive because it's the composition rate.
Yeah, so there should be no sign. Can you get my point? The number must be positive, but not negative. So philosophical to have an average rate of decomposition having a negative number. So this is 2.67, but because we have got the significant figures being 2 only, is 2.7 times 10 to the power minus 5. Check the unit, please. The unit is wrong. How do I know the unit? You're going to take a look on this over this. Do you understand? Can you?
Yes.
So you may get it as mole per dm cube per second, but not mole per second. Check this unit in the graph. Now, so for the final questions comes to Ho Qiwan. What is the average rate, initial rate of consumption of N2O5? Initial rate.
0.015 over 470, which gives
400. What timing will you get another data? 417.
Yes.
Wow,
70,
so
70.
470. Where? 470. This one, this point?
Yeah.
Wow.
So
nice. Of course, 2-point form is also okay. But indeed, in the dotted line, just choose whenever 2 point, and you can get the same answer. You know it? Because it's a straight line. It doesn't matter. Please tell me the coordinate of this. It is 470, and then 0.0 something. 4 small grid.
喂，唔好吸塵住啊！喂，好嘈啊！hello 喺度。喂，媽。
係。點啊
？hello。
喂，點啊？阿哥哥，早收工啊！食飯啊，快啲啊，喂！點啊？
我知道。
你玩嘢你自己刁轉嘅，你揾個470，你揾個嗰啲咁嘅數。頭先你 feel 唔 feel 到頭先我暗示緊你啲乜嘢啊？你要揾啊，你要揾都唔好揾呢啲啊，大佬，你數死自己。你梗係數嗰啲啱啱踩住喺啲粗線位嗰度，你咪容易啲數咯，係嘛？我頭先咪暗示咗俾你聽咯，喺呢條虛線上邊，任何揾2點都係一樣噶嘛。
係啊，
係嘛？第1點一定係呢個噶啦，
因為 slope 一定係一樣噶嘛 slope。
係啊，咁你而家話我聽呢4格即係咩咧？你話你數到噶嘛？都唔吸塵啊！咁你而家應該知啦嘛？幾多啊？
當佢0.01咯。
0.01？
唔係咩？你唔係話個 slope 係
點啊？你而家揾邊點啫？你而家咪揾緊呢點啊？
係啊。
咁你嗰個 y coordinate係乜嘢啊？0.01啊？咁呢個咧？咁呢個叫咩啊？
呢個咪 y coordinate 嚟嘅。
係啊，你唔死啊！真係。
歐軒唔好笑啊！歐軒，我數學好差嘅，唔好再笑啦。
我笑唔出啦。你話俾我聽啦，呢點係咩嚟㗎？咁你而家咪要 up 呢一點嘅 y coordinate 咯。但係你 up 呢一點嘅 y coordinate，如果你講緊470.01嘅話，就唔係呢度啦，就係呢度嚟㗎，知唔知啊？你呢點嚟㗎？呢點咧就係470.01啦。咁而家呢點呢個 number 係乜啊？
係咪我當個0。
咁呢點咧？咁呢點咪就係470咯。咁呢點係咩啊
？470。
唔係當佢0啊？咁你唔掂到0，點樣當佢0啊，哥哥？乜鬼啊？
一格幾多？一細格即係幾多？
而家咁你自己揾自己笨啫嘛，而家。
0.008。
哦，哎呀，救命啊！點啊？一個大格即係幾多啊？一個大格爭幾多啊？
你講上邊定講下邊啊？
我點知係邊邊啫？你首先大家都 understood 咗，你唔需要去睇左邊嘅格仔啦，所以我好明呢條問題，我就唔係問緊你horizontally 嘅每一個世界係等於幾多啦，係咪啊？因為你由頭到尾你淨係唔知道咩叫 y-axis 啊嘛，所以我咪問你每一個世界係乜嘢，個意思咪梗係問緊你 y-axis 嘅 grid 㗎啦，咁我都冇爭議你嗰470係錯啦，係咪？咁呢個係平時我哋溝通嗰個講嘢嘅方法係咁㗎嘛。咁點會問翻我 x 定 y 啫？定係我唔記得話俾你470係啱啊？咁我呢度講翻聲，唔好意思啦，係啦，470係啱嘅。不過我唔使睇 x 嗰邊嘅格仔啦。請你話翻我聽 y 個每一個格仔其實係代表啲乜嘢？ 咁即係乜嘢啊？唉，阻人收工啊！真係
0.01 over 5
咩啊？
唔係0.008咯，一格仔係
咁而家呢一點係幾多啊
4個0.08咯。即係0.032。
陳宇就答話0.0016，你係0.032，咁邊個淨係啊，大佬？
你等我放大睇下先，我冇 test book，我要睇呢個 screen。一格、兩格、三格、四，係咯，4格冇錯啊嘛，咁一格係，哇，好亂啊，搞到我。
等
我一陣0.01 over 5，然後再
睇亂晒，你望住呢個咁會唔會容易啲啊？呢度係0.0，而家全部都係0.0噶啦，係咪？跟住咧呢度你咪1啊嘛，咁咪1嚟咯。咁呢度全部都係有2格噶嘛，咁呢度係咩嚟㗎？呢啲咩數嚟㗎
？08、06、04、02。
係。咁呢個答案係咩啊？
哦，016。
仲有係咯，做乜搞咁耐啊？使乜掉翻去初中啊？
唔使啦，唔使。我會檢討下㗎嘛，我會。
嘅啦，你搞到個餓咗咁多個字，你餓10分鐘啊，喺度等緊你喺度數格仔。唉，咁你而家嗰個答案係啲乜嘢啊？而家有晒數據啦。Initial rate of nitrogen dioxide 大 nitrogen peroxide 幾多？
係咪3.4042咁樣啊？再乘以10嘅 power 負6。
3.40乘10嘅 power 負6。
唔係
幾多人咧？佢係咩？點樣計㗎？點樣計佢嘅 slope 啊
？y over x 咯。
邊個 y 邊個 x 啊？你而家有2個數 y 嘅數，2個 x 嘅數咯。
係喎。Oh my gosh。y 係0，咁即係等於0.16。
跟住咧，
再 over 470。3.9148。3.9148乘以10嘅負5。我已經 feel 到佢哋啲眼光好似鄙視緊我啦。已經。
首先第一樣嘢，何超華你漏咗個負。我如果根據 y2 減 y1 除 x 減 x1咧，呢一個數係第一個數係細過第二個數嘅，擺明一定係負數。係啊。咁我而家咧計緊係 consumption 啊嘛，用咗幾多嘛，咁所以用咗幾多嗰時，嗰個數根本係一個正數啦。如果你冇係用負數，咁用負數咪就唔係 consume 啦。咁係個 logic 嘅問題。逢親見到 decomposition 啊 consumption 嘅話，你計個 stop 咧，前面一定俾個負號啊。第二，寫完咗呢個之後，下一步做咩咧？咁係3.9乘10嘅負5，單位錯，做乜都冇用噶啦。
mole per dm per second。
係啦 ，mole per dm per second 啦，得唔得？OK， 其他同學跟唔到。嗱，如果我係畫緊一個叫 formation production 嘅話咧，嗰個 curve 嗰個 curve 你畫嗰個 tangent 個 slope 係正數嘅，咁你唔會覺得有問題嘅，因為你好順理成章地你會話到係正數咪正數咯。但係 consumption 嘅話就有個伏位嘅， consumption decomposition 嘅話咧，就係你應該係畫緊你本身嗰條曲線係向下走噶嘛。向下走嘅話，我畫佢嘅所有嘅 initial rate 好 instantaneous rate 都好咧，你都係畫緊一條斜線向落㗎。如果斜線向落嘅話，咁即係話我計緊嗰個叫斜度咧，一定係負數啦。咁但係我明明就話俾你聽 decomposition 嘅 rate 啊嘛，分解嘅速率啊嘛，咁分解呢個動作就已經意味住用咗嘢啦，咁冇理由計得出嚟負啊嘛。所以我哋嘅數據處理咧，一見到呢兩隻字咧，前面一定要打個負號俾佢，明唔明？嗱，如果你對於個 concept 上邊唔明咧，都唔緊要。最後一樣嘢要再做咩咧？你睇翻個答案，答案係一定唔可以係負數。如果你漏咗個負，你前面要加個負，得唔得？嗱，呢個係最低層次嘅提醒啦，冇同 Chem 關係㗎。頭先嗰句説話，你要明 concept 嘅話，就係我話俾你聽啦。consumption decomposition 牽涉到用嘅 concept 啊嘛，所以佢係用咗一個數咯，用咗一個數，佢用咗意思就係一個負嘅意思啦，明唔明？咁你個負就一定要再出現翻，如果唔係咧，你就要你就出現咗用咗負嘅問題啦。用咗負咁即係咩咧？用定冇用到咧？咁啊唔啱啊嘛，個 concept 係錯嘅，得唔得？咁 today we have gone over review the 4 questions. So for Chem 2 lesson, we will continue for the other 4 questions. So Chem 1 and Chem 2 students need to watch the video of the other class later on. So the next lesson for Chem 2 will be for next lesson. There should be next Tuesday, isn't it? Next Tuesday. So after Tuesday, upon Wednesday, I will check all your work. You can finish them all. Okay. Questions? Is it better that you better understand what is happening in this chapter? I find your class would have some problem of understanding those. Now, this is very important. If you don't understand this, it will be problematic while you study Form 6 and chemistry in electives, the industrial chem. This is the foundation part. And you should be highly capable in dealing with mole calculations, as you may see here. I've just told you. Okay, all of you, could you please mark your level of understanding today? Better. Number 6 is better than 5 and 4 yesterday. I found quite a number of you mark it 4 and 5. Today is better. Now, any more questions that you want to raise? Any difficulty? Now it's time to have lunch. For those who want to have some questions to ask, you may stay behind and ask me. For the others, you may now be dismissed. Bye-bye.
Bye-bye.
I see, sir.
Bye-bye.
Bye.
Bye bye。
请起来，请起来。